Celestial objects. Silent threats moving through the solar system. They are not just rocks floating in space. They are the same objects that gave us jewelry, gave us the rare metals used in our phones. And in fact, even in the origin story of the water you drink, they played a role, somewhere behind our existence. These celestial objects also had a part to play, but sometimes they have also been the reason for mass extinctions. So what is the secret behind them? Why are they a potential threat to us? And what will our relationship with these objects look like in the future? This entire series has been created to answer these questions. If you subscribe to the channel and press the bell icon, you won't miss a single episode of this Planetary Defense series. And if you think this knowledge should reach more people, share it with your friends and family, so awareness about planetary defense can grow. Because this is not an issue of just one country. It is an issue of our home. And if a threat ever comes, it will not stop to check borders. So let's begin today's episode. It all began about 13.8 billion years ago. We call this event the Big Bang. The Big Bang was not an explosion that happened inside space. It was the expansion of space itself. Time, space, matter, everything began to exist from that moment. In the beginning, the universe was extremely hot and dense. As the universe expanded, the temperature kept decreasing. Within the first few minutes, the simplest elements like hydrogen and helium were formed. At that time, there were no planets. And there were no stars either. Only hot plasma and gradually cooling matter. A few million years later, gravity began to do its work. Huge clouds of hydrogen and helium started collapsing under the effect of gravity. When these clouds compressed, their centers became so hot that nuclear fusion began. And this is how the first star was born. Inside these stars, a cosmic factory was running. Hydrogen fused into helium. Helium fused into carbon, oxygen, and heavier elements. But there is one important thing. Heavy elements are not formed inside normal stars. They are formed in supernovae. When massive stars reach the end of their lives, they explode. This explosion is called a supernova. During a supernova, the temperature and pressure become so high that heavy elements like gold, uranium, and nickel are formed. Yes, the gold you wear was formed from the death of a star. That means gold was born from destruction. This explosion is not just the end of a star. It is the beginning of future solar systems. Because after a supernova, all these heavy elements spread into space. New clouds of cosmic dust and gas are formed. And within these enriched clouds exists the material from which future planets, asteroids, and comets can form. And in this same way, about 4.6 billion years ago, in a corner of the Milky Way galaxy, one such enriched molecular cloud began to collapse. Because of this collapse, planets, asteroids, comets, and even a star were formed, but the entire cloud didn't turn into planets and a star. Some rocky, metallic, and icy objects were left behind. And even today, they're moving around the solar system as a silent threat. Now, before understanding their locations, let's first understand the forms in which they exist. So, usually, celestial objects are divided into 5 categories: asteroids, comets, meteoroids, meteors, and meteorites. I know this sounds a bit confusing, but it's actually very simple to understand. So, asteroids are objects that orbit around the sun. That means they should not orbit any other planet. Otherwise, they won't be considered asteroids. And they must be metallic or rocky. If they're icy, they won't be called asteroids. Now, the reason I'm saying that icy objects aren't asteroids will be explained later in the video. Also, size doesn't matter when identifying an asteroid. An asteroid can be 1 meter wide or even 1,000 kilometers wide. So, to identify an asteroid, you only need 2 things: its orbit and its composition, which is usually rocky or metallic. Next comes meteoroids, and to identify them, you also need 2 things. First is their size. If a celestial object is smaller than 1 meter, it's called a meteoroid. If it's larger than 1 meter, then it would be considered an asteroid. And it must orbit the sun, otherwise, it won't be called a meteoroid. Usually, meteoroids are just broken pieces of asteroids. Then come comets. Comets are the most interesting among all of these. They have four main characteristics: composition, orbit, tail, and appearance. In terms of composition, they must be icy, usually made of water ice, carbon dioxide ice, which we call dry ice on Earth, and methane ice. Then comes their orbit. Their orbit is very unusual. They don't move in a normal circular path around the Sun like asteroids. Instead, they travel in highly elliptical orbits. This means they can get very close to the Sun and also go extremely far away from it. One orbit can take many years. For example, the very famous Halley's Comet follows a highly elliptical orbit and comes close to Earth once every 76 years. The rest of the time, it mostly stays in the outer solar system. Then comes the tail. When a comet is far from the Sun, it remains in a normal icy state. But when it comes close to the Sun, the heat causes the ice to vaporize and stream into space, forming what we call a comet tail. And finally, its appearance. Whenever a comet enters the inner solar system, it becomes visible through large telescopes on Earth. But it doesn't appear sharp like a star. It looks very faint and blurry, almost like a few pixels. From this blurry observation, scientists study its structure. For example, its nucleus, which is made of ice and can be several kilometers wide. Then comes the coma, which is a cloud of dust and gas surrounding the nucleus and can extend thousands of kilometers. And finally, the tail, which can stretch for hundreds of thousands of kilometers into space. These four characteristics help us identify a comet. Next come meteors. You've probably heard about them many times, like in the news saying there will be a meteor shower at midnight. But what are they actually? Meteors are celestial objects that burn up in Earth's atmosphere. They are very small, usually between 1 millimeter and 1 centimeter. An interesting fact is that more than 20 million meteors burn up in Earth's atmosphere every single day. That means around 300 to 400 meteors burn up every second. If our own weight increases by even 500 grams, we start worrying. But Earth gains more than 40 tons of mass every day. That means every day, over 40 tons of space material is added to Earth's mass. Pretty interesting, right? Now let's understand the last celestial object, meteorites. Meteorites are objects that actually reach the ground. So, if it burns up in the atmosphere, it's a meteor, but if it survives and lands on Earth, it's called a meteorite. And sometimes, they can be extremely destructive. For example, the Chicxulub meteorite, which led to the extinction of the dinosaurs. At this point, you might also see a tree diagram showing all these celestial objects, from the Big Bang to meteorites.